As we've dealt with quadratic functions, we have discovered that a quadratic is any function that's in the form of ax squared plus bx plus c, where when you set the y value equal to 0 so that you can solve for the x value, what you're really doing is you're finding the value of x when y is 0, which is called the x-intercept. There's also a couple of other words that these are called. These are called the roots of an equation or the zeros of the function. But in visual terms, what this really means is if you were to have a parabola that opens up, and remember, if it opens up, it means that a is greater than 0. If you have a parabola that opens up, the zeros are where I cross the x-axis. If you have a parabola that opens down, the zeros are where it crosses the x-axis, and in this case, a would be less than 0 or negative. But there's also other instances where the zeros of the function are not just one number, are not two numbers, but they can end up being no solution, which would mean if you were to have something such as the following, where you have a parabola that opens up and never crosses the x-axis, and it could look anything like this in any location really, or if it opens down similarly and never crosses the x-axis. This means that there's no solution. That means that you can't find the value of x because there is none where it equals 0, where y is equal to 0. This is where the discriminant, which is the b squared minus 4ac part of the quadratic formula, it means that the inside must have been negative. Then there's also times where when you have parabolas, you may cross exactly just one time. So it might look something like this, where your parabola crosses only once on the x-axis. That means it's one solution. And not only is it just one solution, but the vertex is the solution because the vertex is the point that crosses the x-axis. I'm sorry if I said y-axis before, the x-axis. And similarly, if I was to have a parabola that opened downward and it crossed the x-axis at one point, it would mean that the vertex is that one solution. And in the discriminant, which remember is the b squared minus 4ac, which is the inside of the square root of the quadratic equation, and this means that the discriminant is actually equal to 0, so that when you take the square root of 0, you only get one solution. That's what this represents here. So, quick review on quadratic equation. If I was finding the solutions or the x values when y is equal to 0, you could use x equals opposite b plus or minus the square root of b squared minus 4ac all divided by 2a. That is the entire quadratic equation. And this quadratic formula or quadratic equation is finding the x-intercepts, the roots, the zeros, whatever it is you want to call it, which are essentially where and if I cross the x-axis. So with that, because of the fact that we are in a round planet and gravity is pulling us down, anytime that you throw something or there's a projectile, it actually follows a path of a parabola. And when this happens, or whenever you have a parabolic shape, you can use the functions that are quadratic and all of the rules that they follow in order to find specific things. For example, if I was to have Colin throw a ball and that ball was thrown in this direction, it would actually follow a parabolic shape. And with that parabola that you get, there's a couple of things that you can discover. Let's say he kicked the ball so that it starts off at the ground. We know that if this is the ground, the parabola, and I apologize for my unstraight ground, but let's just make believe that that's straight ground. The parabola, or the ball, would reach the maximum height before it starts getting pulled back down to gravity, or by gravity. It would reach its maximum height at this point right here. On a graph, that is what we call the vertex. That's the maximum. Now, with that, if I was to try to find out how much time it took for the ball to get to that point from the moment that Colin kicked it, the time that it would take would actually be this right here, which is the x value. That's how long it took for it to reach that maximum height. And then once it came back down, the total time that it would take for the ball to go from Colin kicking it all the way to hitting the ground again would be the entire distance here. And remember that the vertex separates the parabola into two exact equal halves. And so therefore, if I find out how long it took for the ball to get to the highest point, then the ball is going to take that much longer to reach the ground again. In other words, it takes 2 or twice as long to cover the entire distance as it would for it to reach its maximum height. So when we have questions that deal with something such as this, we will use the function y equals, and in this case, let's say it's negative 16x squared plus 16x. This is a function that engineers, mathematicians, scientists discovered represents the maximum height, or the height of a projectile, is equal to gravity pulling it down at this many feet, or per second, so feet, and this is per second, time, multiplied by the velocity at which the object was going at for the amount of time that it was going. So you're seldomly going to have to create these equations. They're going to be given to you. But anytime you have a quadratic function, it is telling you that it is a parabola shape. So let's look at some real applications. The height of a soccer ball that is kicked from the ground can be approximated by this function, where y is the height of the soccer ball in feet and x is the seconds after it is kicked. Find the time it takes the soccer ball to reach the maximum height. So if I bring over the parabolic shape that we did in the previous example, what it is asking me to find, first of all, is the time it takes for the soccer ball to reach its maximum height. So it is asking me for this right here. How much time, because they tell me x is the number of seconds. They want to know what is x equal to so that it reached its maximum height. And the maximum height is y. So if I was to look at this, I can figure out based on the following. I know that the equation I'm being given is this one. I am really being asked to find the x value of the vertex. That x value of the vertex is the axis of symmetry's function. Remember, the axis of symmetry is that vertical line that cuts that parabola in half. And the axis of symmetry is found by using the equation x equals negative b over 2a, where in this case the b's positive 16, so it's negative 16 over 2 times, and a is negative 16. And I get negative 16 over negative 32, which gives me positive 1/2. This is telling me that it takes half of a second to get to the maximum height. Now, if it's also asking me how much time it takes for it to return to the ground, that means that it's asking me from the moment I started, how long does it take for me to reach the ground again? Well, we just found that it takes half a second to reach the maximum height. That means that it's going to take another half a second to reach the ground again. So it is going to take a full 1 second for the ball to go from the moment it got kicked all the way back down again. Now, what if it asks you, in addition to this, what is the maximum height that it reached? Well, if I am asked to find the maximum height, what they're really trying to find is the value of y when I am at the highest point. And the value of y when I am at the highest point is going to be the value of y when x is 1/2. So using my equation, I am going to plug in that 1/2 to find out what the y is equal to. And when I do that, order of operations says you do exponents first. 1/2 squared is really 1/4. 1/4 times -16 is kind of like saying what is -16 divided by 4, and that is going to give you -4. And then half of 16 is actually 8, so this is really -4 plus 8, which is 4. This is telling me that the maximum height is going to be 4 feet off the ground, because when half a second happens, you are at 4 feet off the ground. This is my vertex. Let's look at another example. A kicker starts a football game by kicking off. We know once more that anything that is a projectile on Earth covers a parabolic shape, follows a parabolic shape. If that ball is going to be kicked off, they want to know how long the football is in the air. So they want to know from the moment it gets kicked off all the way till it reaches the ground, how much is the value of x? Well, we know, once more, that we're trying to find a couple of different things. The first thing that you could do is looking at it the way that we looked at the previous example. Find the maximum x value using the axis of symmetry and then double it, and then you would find when it hits the ground. But also, if you think about what this is actually representing, if we were to overlap a coordinate plane on our parabola, we are really being asked to find when I'm on the ground after it gets kicked. So I'm looking for this point and this point. And those 2 points, if you recall, are, with a parabola, the roots or the solutions, the x values when y is 0. So the other way that you could solve this is by setting this equation equal to 0 so that you can find the value of x when y is 0, which is the x-intercepts. You want to know when I am on the ground. When as in time, and time is x seconds. And so if I was to do that, I could solve by factoring or the quadratic equation or square roots. In this case, I am actually going to solve by factoring. And if I was to divide or factor out something from 16x squared and 60x, I would be able to factor out 4, let's say -4x, because we always want to factor out the negative if the leading coefficient is negative. And you're left with 4x and then minus 15 equals 0. And then as we learned how to solve by factoring, you factor and then you set each parentheses or each part equal to 0. So we're going to set -4x equal to 0, and we're going to solve, and when we solve this, divide by -4. You get that x is 0. This is telling you that when x is 0, you're on the ground, obviously, because you haven't kicked it yet. And the other part is setting 4x minus 15 equal to 0, and then added 15 to both sides, and you get 4x is equal to 15. We divide by 4, and because we're dealing with seconds, you're going to actually divide 15 by 4, and you're going to get 3.75 seconds. So that means in reality that my graph, and I over or imposed or under, whatever you wanted to call it, I put the coordinate plane right over the parabola that I had drawn. So these numbers are inconsistent. Really what this should be was 3.75. So here's 0 and this is 3.75. That means that it took me 3.75 seconds to get from the moment it got kicked back down to the ground. Now let's look at this one. Again, the height of a rock thrown off of a cliff can be modeled by, and they give me the equation. So this is basically what it's telling me. I had a cliff, and I threw a rock off the cliff. So it followed a half of a parabolic shape. Just so you know, this here is the y-intercept of the parabola. But what it represents, that 120 in the real world, is that it was 120 feet off the ground when it started to fall. The negative 16, which is the constant thing that we have in every parabolic shape projectile, is gravity. And the negative 8 is representing the velocity at which the ball or the rock was thrown. So they want to know if h is representing the height and t is the time, how long does it take to reach the ground? So if I look at my equation, I know that what they're asking me to find is what is the value of t when the ground value, the height, is 0, because that's when I'm no longer up in the air. So when I do this, the first thing that I would probably do is remember that when we are asked to find this or to solve a quadratic, there's lots of different ways you can do it. The first way is to factor, and if I was to factor, I would factor out negative 4 from everything, and I would be left with 4t squared minus 2t plus 2t, because remember, you're factoring out negative 16 divided by negative 4, negative 8 divided by negative 4. 120 divided by negative 4 is negative 30. And then I realized, oh, I could have factored out even more. Because, believe it or not, maybe you didn't realize it, but 120 is actually divisible by 8. So since I see that all of these are still even and could be factored out by an additional 2, I could go in and go, oh, let me then, instead of factoring negative 4 out, let me factor negative 8. And when I do that, I'm left with 2t squared plus t minus 15. From that, I remember that to factor, you could do product of AC, sum of B. So what numbers multiply to negative 30 that add to 1? And the answer is 6 and 5, positive 6 and negative 5. These are the expansion of the middle term. So I rewrite the negative 8, I rewrite the 2t squared. The 1t now becomes plus 6t and minus 5t. And then rewrite the minus 15. I can then group factor, as we called it, where I could take out a 2t from here, and I'm left with t plus 3. I could take out a negative 5, and I'm left with t plus 3. The negative 8 is still there, although it's going to be kind of irrelevant in a minute. Then I look for my, what we called twins, and I get t plus 3 and 2t minus 5. The next step is to set each part that has a variable equal to 0. So I set up my two parentheses. I set t plus 3 equal to 0, and I set 2t minus 5 equal to 0. And when I do that, I'm going to get that t is -3, so that's telling me that 3 seconds before I kick the ball, I'm on the ground, or before the rock is thrown. So that's irrelevant because that's a real world application. You can't have negative time. And then the next one, you would add 5, and you get 2t equals 5. Divide by 2, and you get t is equal to 2.5. That means that 2.5 seconds after it's thrown, it's going to reach the ground. Because at that point, your value of h is 0. Sometimes it's not just projectiles that we're dealing with. There are parabolic shapes everywhere in the world in real applications. Take, for example, an airplane hangar. If you have an airplane hangar that is shaped as a parabola, and we ask you that following, they're able to calculate the equation, and they discover that the equation is actually y is equal to -0.2x squared plus 1.6x. The x, in this case, isn't seconds that's up in the air. The x is the horizontal distance. It's the horizontal distance in feet, let's say, from one wall to the next. And the y value is the height. So it could be any of these here, depending on what the x is. Remember, this height is really dependent on what the x value is here. This height is what the x value is here. But the maximum height of the hangar is considered to be this part right here, because it's sort of like the radius of what a circle would be, if that's the case. So the maximum height would be there. We know that this point here is the x comma y vertex, where x is the axis of symmetry and y is the value of y when you find your axis of symmetry x. So if I asked you, what is the maximum height of the airplane hangar, you would really be asked to find the value of y at the vertex. So in order to find that value of y at the vertex, remember that what you're going to do is you are going to find the x value, which is the axis of symmetry, and then once you find the x value, you are going to find the value of y at that point, or at that location. So let's start with the axis of symmetry equation. X equals opposite, in this case b is 1.6 over 2 times a is -0.02. When we do our math, we get 1.6 in the numerator, negative, and 0.02 multiplied by 2 as a negative is 0.04. Negative 1.6 divided by 0.04 is 40, positive. This is telling me, going back to my parabola, that the x value is 40. So this is really 40 feet from the wall. Now I want to know what is the maximum height. So what is the y value? And in order to do that, you plug in that x value because you know that this is 40 comma and you're asked for the y. So you plug in that x value and you try to find what y would be. Remember your order of operations. In this case, you are going to square the 40 first. So we do 40 squared and it gives me 1600 plus, and 1.6 times 40 is 64. 1600 times 0.02 is equal to negative, obviously, negative 32 plus 64 gives me positive 32. That means that when my x is 40, which again, going back to the parabola, when I travel to the middle, 40 feet, the maximum height that I am going to reach is 32 because this is located at 40 comma 32. So the maximum height of my hangar is 32 feet tall.